Hello, today we're going to talk about the basics of right triangle trigonometry. I'm going to start you from the beginning like you've never seen it before and then walk you step by step through several examples. Let's first start off with this little saying of mine that I like. It's called Oscar had a heap of apples. And I know you might be thinking, what on earth does this have to do with trigonometry? Well, it's just a saying to help us to remember the sides of these triangles or the ratios that we're dealing with. So H, AH, and OA. Look at these as fractions. And so this saying is what I first learned trigonometry with, and it helped me remember the ratios of the sides of a right triangle. What does that mean? We'll get to it here in a moment, but let's take a look at it like this. Here is your Oscar had a heap of apples. OH, AH, OA. And this stands for our sine, our cosine, and our tangent. And I put a picture of a calculator here to remind you that almost on every calculator it's listed in that order: sine, cosine, and tangent. Don't believe me? Check out this calculator I have right here. On it, we've got, if you can't read it, it's a little bit out of focus for where it's sitting, but it says sine, cosine, and tangent right there. Let's see if we can bring that into focus. There it is. So it's in that order. So if you can remember Oscar had a heap of apples, then you can look at your calculator and go, first one listed here is sine, the next one listed is cosine, and the last one is tangent. Now inside of here I put theta. You may or may not have seen this before. Some teachers use x, some teachers use other variables, but theta I like to use because in mathematics we use theta to represent an angle. And I don't think I can think of any other time when we used the Greek letter theta and we were not talking about an angle. I'm sure there are times out there. But I want students to look at this and say, that looks really weird. What does this theta right here stand for? And I want them to remember that it's standing for an angle. An angle always goes inside of that set of parentheses there. This is the opposite side in a right triangle. That is the hypotenuse. And then A stands for adjacent. So these words right here, let me give you a breakdown of, or these letters, let me give you a breakdown of what they mean. O is opposite, H is hypotenuse, and A is adjacent. Anytime you take a quiz or a test on trigonometry, you should be writing out Oscar had a heap of apples, and then you should write out the sine of theta, the cosine of theta, and the tangent of theta. Now, you'll see a lot of teachers do not use this. Instead, they use SOHCAHTOA. And so I get students coming to me all the time that have had geometry before. Maybe they're in my pre-calc class, maybe they're in one of my other classes, my physics class, and they use SOHCAHTOA. I'm completely fine with them using SOHCAHTOA. If that's the way you like to remember it, do it that way. I don't teach it that way in my geometry class or my pre-calc class, or any of my classes for that matter, because I want students to see these equations written out right here. I think it's already set up for you. Sine of the angle equals opposite over hypotenuse. Here, you know, sometimes students spell so wrong, or so they spell so wrong, or ka wrong. They put an O in here. And so I think it can mess you up. Other students get it right every time using SOHCAHTOA. So whatever works for you, that's what I want you to use in my class. Now, this first problem right here is a very basic one. It's saying, here's a right triangle, just list the ratios, all right? That's what trigonometry is, at least right triangle trigonometry. We're talking about the ratios in a right triangle. So you give me an angle. In this case, our angle is theta, and it is listed right here. What is that angle? We don't know yet. We don't really care in this problem. I just want to know, in reference to this corner in the triangle, or this angle in the triangle, what is the opposite side over the hypotenuse? So what do I mean by opposite side? Well, I think a lot of students understand what a hypotenuse is. The hypotenuse is the side across from the 90-degree angle. They learned that back when they learned Pythagorean theorem. And so they usually have an easy time identifying what the hypotenuse of a right triangle is. It's the other two that usually give them trouble. So what I want you to do is first identify your hypotenuse. Get that out of the way. And then next, I want you to identify the opposite side here. Now, the opposite side, you find it just like you do with a hypotenuse, except for we're looking at the angle that we're talking about. Here, theta is in the bottom right, and the opposite side of it is across from it at 8. So this is the opposite side. Once again, the hypotenuse is opposite the 90. The opposite side, when we're talking about in right triangle trigonometry, is opposite the angle, okay? And so I can go ahead and list those out if I need to. The only thing I got left is adjacent. We got the hypotenuse, we got the opposite side. The adjacent side is what is left over. So in this case, our adjacent side is going to be right here. That's your adjacent side. And now all this problem is wanting you to do is write out these fractions when theta is this angle and this particular triangle. So when I write those out, this is what I get. The sine of theta, well, that equals opposite over hypotenuse. So the opposite side is 8 and the hypotenuse is 17. The cosine of theta is adjacent over hypotenuse. So in reference to this angle, the adjacent is 15 and the hypotenuse is 17. And lastly, the tangent of theta is the opposite, well, here it is, the opposite over the adjacent. So the opposite side is 8 and the adjacent side is 15. And that's all there is to it, okay? Now, that's how we fill out just finding the ratios. There is meaning behind this that we'll get to in a moment, like when do we use trig, why would we want to use it, and how does it work? Those questions will be answered later, but right now I'm just wanting you to get practice with setting up the ratios, all right? Now, let's look at something that looks a lot like this problem right here. This one right here. Now, take a moment, look at your notes that you're taking, and compare this problem with the last one I just gave you. Let's go back and look at that. There's your triangle here. Here's our triangle now that we're talking about. What's the difference between the two? The difference is theta right here. And see how theta moved? Theta's now up here. So now what I'm going to do is I'm going to do the same thing. You can pause the video if you want and give it a try yourself. Theta has changed to the top right corner. Not top right corner, top left corner. There is no top right corner. How does that change things? Well, let's again identify these sides. I'm going to start by saying, where is the hypotenuse? And so the hypotenuse is across from the 90. And then where is the opposite side? The opposite side is across from theta. And then lastly, we're going to say, where is the adjacent side? The adjacent's what is left over. This is your adjacent. As you learn trigonometry, if this is your first time ever seeing right triangle trigonometry, I want you to write that down every time. If you're just here to review, because you've seen it before, it's just been a while, you judge for yourself. How comfortable are you after watching this? If you're super comfortable, then, you don't have to write it down every time. But if you're just saying, you know what, it's been a while since I've seen this, go ahead and start labeling those things so you don't make simple mistakes. Once again, we're going to compare it to the last problem. All I did was move theta from right here to the top left corner there. And notice what changed. Well, the hypotenuse stayed the same, but the opposite and the adjacent sides switched, didn't they? So be careful with that because that will change up some of our ratios here. So the sine of theta is the opposite over the hypotenuse, or 15 over 17 in this case. The cosine of theta is adjacent over hypotenuse, or 8 over 17. And lastly, the tangent is opposite over adjacent, or 15 over 8. So once again, going back to the previous example, compare the results. Notice that the sine and the cosine values switched there. This was their cosine of theta right here, is 8 over 17. When you switch the theta, the sine of theta becomes 8 over 17. That's because the opposite and the adjacent are in the numerators, and they switched spots when we went between the two problems. The tangent of theta, we got the reciprocal here. It flipped, didn't it? And that's because, once again, opposite and adjacent switched spots, and it was opposite over adjacent. So if you switch those, it's going to flip. So where theta is in the triangle, the reason why I gave you almost the exact same problem, where theta is changes opposite and adjacent. All right, so those things are going to flip around, and it will give you different results. So it does matter where theta is because it changes the labels. Doesn't change the hypotenuse label, but it changes the other two that do matter. Some students ask me, will the 90-degree angle ever be theta? And for right triangle trigonometry, no, it won't. All right, it's going to be one of the two acute angles. When we get into other stuff in pre-calc, we'll see some 90-degree angles and angles that are bigger than 90. But with right triangle trigonometry, you really don't have to worry about that. All right, what I'm going to do now is I'm going to, let's see, start you off with a problem of how we can use it. So we can use trig ratios to find the lengths of sides in a right triangle. So here we are, we've got this triangle going on, and we want to find the side lengths x and y. Notice that we cannot use the Pythagorean theorem here. Why can we not use the Pythagorean theorem? Because we only know one side. Pythagorean theorem says a squared plus b squared equals c squared. You got to know two of those three things to solve for the third one. Do we know two of the three right here? Take a look at it. I only know one of the sides. Now I do know an angle. So what I want to do is call this angle my theta. Remember, going back to, let's see, this right here, I said theta is always an angle. So what's written in the parentheses there, that's always going to be your angle. In this case, if I'm writing out the trig ratios, I'm going to put 25 in for theta. All right, so I'm going to first highlight, boom, here's my theta, 25 degrees. Could you use this? Yes, you could subtract 25 from 90, but I'd say if they already gave me the angle, use that angle given. Now, across from the 90, identify your hypotenuse first. Y is my hypotenuse. Across from the 25 is the opposite side. And then lastly, we have adjacent side. Now, you tell me, what do you want to solve for first? I'm listening. Oh, you want to solve for x first. Okay, let's solve for x first. I just took a random guess and figured for half the time I'd be right on that, so maybe I freaked someone out that said x. All right, so if we're solving for x, I don't care about y in this case, okay? I don't know what y is, and right now I don't want to know what y is. I want to know what x is, and I want to know what the opposite side, or I do know what the opposite side is, okay? So I'm going to use this little guide right here. In fact, I'm going to cut it out right now so we can bring it to each page as we go along. You can write it out. Oscar had a heap of apples. I think it's good practice. But since I'm going to be doing a lot of trig problems with you, I prefer it just to go ahead and be cut out for me to move to each page. So here we go. I'm going to use this guide to help me pick out which equation to use. I'm going to let the problem here decide for me. So this is opposite and adjacent. Notice only one of these uses opposite and adjacent. Which one is it? It's the tangent function. It uses opposite and adjacent. So because my problem told me the opposite side and I want to know the adjacent side, that tells me use the tangent function because we are dealing with both opposite and adjacent. So the tangent of my angle, 25 degrees, is equal to the opposite side over the adjacent side, which is just x. And I need to solve for x here. So to solve for x, you can do multiply both sides by x, and then divide by the tangent of 25. Or I just say this, when the variable is in the denominator, we can do what we call the switch 'em property. So I'm going to take x, I'm going to take the tangent of 25, and I'm going to switch the two. This is not an actual mathematical property, it's just skipping over a few steps. 10 divided by the tan of 25 is what I get here. That should be the value of x. So if I bring out my calculator, and I say, all right, what is 10 divided by the tangent of 25? I get 21.4. So 21.4 is the length of x here. Now, a few things to note. If you're not using a calculator that looks like this one, the TI-30X2S, and say you're using a graphing calculator, you want to make sure that your calculator is in degree mode. So look up how to do that if you don't have it in degree mode. Usually you click the little mode button and make sure degree is highlighted. Otherwise, you may not be getting 21.4 when you put in your answer. Now, from here, we could use the Pythagorean theorem to solve for y. You can say that 10 squared plus 21.4 squared must equal y squared and solve it. But we're learning trig here, so I don't want to use that. I'm going to continue to use trig. So let's pretend like the problem didn't even ask for x. It just wants to know what y is, if that's 10 and that's 25 degrees. Once again, I'm going to let the problem tell me which trig ratio to use. I know the opposite side, and I want to know the hypotenuse. And I know the angle here. Which trig function uses opposite and hypotenuse? Looking over here, it's my sine function. It's the only one that has both opposite and hypotenuse in it. Cosine has hypotenuse, tangent has opposite, but the other option there is adjacent, and I don't have, or I do have the adjacent side now, but I'm going to pretend like I don't know the adjacent side and just use that 10 there. Now, the reason why I'm using that 10 is because we rounded that number. I like to know, like, hey, that is the exact number, and I'll get a closer approximation to the actual answer there for y. So using that, I'm going to say, okay, the sine of 25, my angle goes right there, is equal to opposite over hypotenuse, or 10 over y. Once again, my variable is in the denominator. Only when that variable is in the denominator can I do that switch in property I did right here. So I'm going to switch them, and I get y equals 10 divided by the sine of 25. And punching that into the calculator, let's see, 10, clear, 10 divided by sine of 25 gives me 23.6. So this is 23.6. Just to check, it should be larger than the other two because it is the hypotenuse, and it is. That's a good thing. And we can move on to the next problem. All right, here we are. I want you to pause the video and solve for x and y. All right, as we go through this, remember we're going to label our sides first. So here's my angle. Across from it is the opposite side. Across from the 90 is the hypotenuse. And then the one left over is the adjacent side. I'm going to solve for x first, just because I want to. So solving for x, what am I going to do here? Well, I want to know the opposite side. I know the adjacent side. So I need to look at this and say which one uses opposite and adjacent. Once again, we're going to use our tangent function here. So I'm going to say the tangent of my angle is equal to the opposite over the adjacent, or x over 7. Now in this case, I'm not going to use the switching property because the variable is not in the denominator. I'm simply going to look at this and say, hey, I need to get x by itself, multiply both sides by 7. So when I multiply both sides by 7, these cancel, and I get x equals 7 times the tan of 64. Punch that into your calculator. 7 times tan of 64, and I get 14.35, or 14.4 is equal to x. So there we are, 14.4. That gives me my x value. To find the y value, I want to know the hypotenuse, and I know the adjacent. So the only one that uses adjacent and hypotenuse is cosine. So I'm going to use the cosine function and say cosine of my angle is equal to the adjacent over the hypotenuse, or 7 over y. Now, here I do have the variable in the denominator, so I'm going to use the switch-on property. And I get the cosine of 64 underneath 7 is equal to y. I'm just switching cosine of 64 and y. And now I'm going to punch that in my calculator. So I type in 7 divided by cosine of 64, and I get 15.9. So 15.9 is my value for y there. All right, let's move it along. Let's take a look at this one right here. Pause the video and give this one a try. All right, I take it you took a second, paused it, gave it a try. Let's start off by looking at our angle and labeling our sides. Across from the 90 is the hypotenuse. Across from the angle is the opposite side. And the only one left over here is the adjacent side. So let's solve for x first, because that's what we've been doing the whole video. And then let's see, we've got the hypotenuse and we've got the opposite. Looking at our trig functions here, hypotenuse and opposite, the only one that deals with that is the sine function. So I'm going to say, okay, let's fit that in on the screen here. I've got the sine of my angle, 36, must equal the opposite side, 10, over the hypotenuse x. The variable is in the denominator, so I'm going to use the switch in property, and I get 10 divided by sine 36. So punching that in, 10 divided by the sine of 36 gives me 17. And it's rounded, so, but that is your value for x. To find the y value, I'm going to say, okay, to find y, I want to know the adjacent, and I already know the opposite side. Which trig function uses adjacent and opposite? And it's not that one, it is the tangent function. So the tangent of my angle, 36 degrees, is equal to the opposite over the adjacent, which is 10 over y. Do the switching property, and I get y equals 10 divided by the tan of 36. So 10 divided by tan 36 equals 13.7. That equals your y value. There we go. All right, let's take a look at, let's see, another one here. But this time, I'm going to change it up and say, let's find the value of an angle. So we can also use trig. We just used it to find side lengths when we only know one side and one angle. Really, we know two angles. We know an acute angle and a right angle. Now we're going to use it to find that value of x. So we're going to tackle this the same way. Start off by labeling your sides. Across from 90 is your hypotenuse. Across from your angle, in this case it's the one we want to find, x, is your opposite side, and then your remaining side is your adjacent. So in this case, we know two sides, and we want to find the angle. So the sides that we do know are the opposite and the hypotenuse. So we're going to look at this and say, which of these use only the opposite and the hypotenuse, and we get sine again. So I got the sine of my angle, in this case we're calling the angle x, is equal to the opposite 5 over the hypotenuse 14. And now we need to get x by itself. Well, the issue with that is we got to figure out what's going on with this sine. Like, this is a function, all right? I'm not multiplying x by sine. I'm taking the sine of x. Just like if you were in algebra, sometimes you use that functional notation where you say the f of x, the g of x, the h of x. This too is a function, and we're saying it's the sine of x. So to get rid of sine, we have to do what we call the inverse of sine, because everything in math has an opposite. And in this case, the opposite of sine of something is the sine inverse. So doing that will cancel that out and just give me an x on the left side. But we can't just go around taking the sine inverse of one side of the equation without doing it to the other side. So if I take the sine inverse of the left side, I need to take the sine inverse of the right side. And so when I punch that in, here's how you punch that in. Here's your sine button, here's your cosine button, here's your tangent button. No matter which one you're using, the inverse is directly above it. So in this case, because the problem told us to take the sine function, and I need to find the sine inverse, that's what I'm going to put in. Second key, hit sine, it will give me sine inverse. See how that's written out there? Sine inverse. So second sine key gives me the sine inverse there. And then I'm going to type in this fraction, 5 divided by 14, and hit enter. Once again, your calculator needs to be in degree mode. So if you've got a calculator that doesn't look like this, like it's a graphing calculator, hit the mode button and make sure it's in degree. This gives me 20.9. Now remember that this is in degrees. So x equals 20.9 degrees. It has a unit to it. So punch that in there. All right, give one a try yourself. Let's go through and label the sides on this one. This is hypotenuse. This is my angle, so this must be the opposite side across from that angle, and the leftover one here is the adjacent side. The only trig function that deals with opposite and adjacent is tangent. So I'm letting the problem pick the trig function here. So I've got the tangent of the angle, which I don't know, equals opposite over adjacent, or 8 over 5. All right? To get x by itself, I need to take the tan inverse of both sides. So I'm going to take the tan inverse of this side, cancels that out, gets x by itself. But then that means I also have to take the tan inverse of 8 over 5. So that's what I'm going to punch in the calculator. I get x equals tan inverse of 8 over 5. That little negative 1 up there just means the inverse, okay? So you don't get it confused with tangent. So Clear that out. Second tan will give me tan inverse. And then I'm going to do 8 divided by 5. Hit enter. And I get 57.99, or you can just say 58 degrees in this case. That's your value there for x. All right? So that pretty much wraps it up. We're going to be either finding sides or going to be finding angles when we do right triangle trigonometry. Okay? Let the problem pick the trig function for you. Have that Oscar had a heap of apples memorized. Make sure you're labeling your sides. Let it pick it for you. Sometimes we'll have to do the switching property if the variable is in the denominator of the fraction. Sometimes we'll multiply both sides by the denominator. That's if the variable is up top in the fraction or in the numerator. And then sometimes we'll actually have to take the inverse of both sides. That's if the variable is right there where theta is or where the angle goes. We will have to take the inverse of both sides in order to find the angle or the variable there. Okay, I hope this helps you. If you have any questions on right triangle trigonometry, besides saying it, let me know. Send me a message. I'll be happy to answer any questions you might have. And I hope you are having a great day.